Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So, today on the bench, finally made it, is the Onkyo A-917. Now, this is the one I had in the poll in the comment section, and you guys voted this one as your number one amp you wanted to see. And I explained in the Carver amplifier video, when I made the poll up, I waited a couple days. And then I looked at the poll and it said the Carver was in the lead. So I just grabbed the Carver out of the pile and started working on it. And then a day later I looked again and the Onkyo pulled ahead. So I don't know what happened there. But this one was the clear winner, but it came in second in the books. But we're going to get to it today, so you get to see it anyway. So when I picked up this amplifier and brought it home, I made an intro tape back then, and let's roll VT and watch that. Alright, so today's May 10th 2024, and this is what I just picked up at a garage sale today. And this is an Onkyo Integra A-917 amplifier. Pretty filthy, it's really dirty, and looks complete. Looks like it's not damaged in any way, just filthy. This thing is so dirty and it stinks. It's got a bad stink with cigarette smoke, and so yeah, this is going to be a good one to clean up. Just want to look at the back here. I'll show you a few things. Here's a look at the back. Somebody took the power cord off and put this monstrosity on. It's not even properly grommeted here, but this is Monster Cable Power Line 100 high capacity Ultra Flex. Can't even read it, it's so filthy. But it's a monster cable. It doesn't say, oh here it is, 14 gauge grounded. Nothing wrong with having 14 gauge wire, but when they start calling it ultra high capacity and all these other BS marketing wanking terms, it doesn't add to the desire of it. So very dirty. I'm going to take the top off and blow this out, because I think it's probably full of crap. So let's do that now. Alright. I think the top just comes off. This is filthy. It's like it was set out in a barn or something. Maybe it would come off. Slides back a bit. No, I think I have to take the sides off too. So I knew right away when I picked it up and this thing just about threw my spine out. It's got some serious punch behind it, which is good. We're going to see what we can do with this. This thing is built to make a lot of racket. You can see right now the big pop can sized. Yeah, you got to take the sides off, or loosen them at least. Let me do this. Sides holds the top in place. I don't know if you can see how filthy that is. It's got like wax on it or something. Yeah, that's exactly what it is, wax. This thing needs a good clean. I think a lot of it's going to end up in my ultrasonic cleaner. There's a filth around these RCA connectors, and this is damaged. Looks like it's got a hit. That's the tuner input. Okay. Filthy. Here we go. Ooh, yeah. I think this is a remote unit. Actually, it's cleaner than I thought, but it still stinks like all hell. It smells like pet and smoke and nastiness and maybe mice. I don't know. It's gross. Okay, I think that's going to do for now. It's pretty filthy. Not a lot of dust, but mostly it's caked on. Like this is all caked on, see? Yeah, this is not cool. I'll show you something here. Don't know how well you can see inside here, but this cord is just tacked on, and then there's loose connections. The ground is not connected to anything. So somebody just cut the old power cord off and put this on. I hope they weren't thinking it was going to improve performance, because it's really not how it works. Okay. Yeah, this thing stinks. I might just let it sit out in the sun for the afternoon and let the sun hit it. That's a good disinfectant. But kind of leery because I brought a Harman Kardon AVR into my house. I was scrapping it, and I was scrapping it for parts. And I brought it into my house, and I started ripping it apart on my bench, and there was rat turds or mice turds in it. So I was not pleased about that. Yeah, you gotta be careful where you buy this stuff and where it comes from. And this thing has corrosion down inside. So I don't know. Okay, we're back. So one thing I didn't notice until after I filmed that opening sequence was this Onkyo Integra A-917 is actually from Japan. It is an AC 100 volt unit. Now, whoever owned this before me hacked off the plug and put this thing on. It's got a monster cable, cord, gold plated, of course, gold plated. That's not bad. I like that. It's not often you see gold plated prongs for the outlet. Not that it's going to make much difference, but this cord has to go. This is not the correct one, and we're going to put proper cord on it. Somebody really made a mess of this. So one thing I want to do is try it out, see if it works. So let me get it hooked up. I'll hook up some speakers, I'll hook up a tone source, and I'll get a power source ready at 100 volts, and we'll see how this thing does. Alrighty, I got a tone source connected, speakers, and this 12-foot long power cable here. I have to get to the end of it. So I got my isolation transformer turned down to about 100 volts, 98 volts. Let's plug it in. We are turned off. There's no switch. And right away we're consuming 3 watts. There's a standby transformer in there. And we do have a standby light. So let's turn this thing on. Click. I heard a click. Consuming 18 watts. And I have a tone on auxiliary 1. Let's see here. Speakers A. Oh, here we go. Direct. Tape monitor direct. Hey, there we go. It's mono. Doesn't seem like the balance control has any effect. Let me disconnect one input. Okay. Balance control does nothing. Well, it's indirect right now. Go to tone controls. There we go. Okay, let's put this back. Seems like it's working. Bass, treble, balance. Some distortion on that one. Dirty switch. So it's tape monitor 1. It's got tape 1 and tape 2. Okay, that's direct, and that's through the tone controls. So it looks like it's a runner. Okay, I'm going to try all the inputs, and I'll report back to you, see what it says. So apparently I've been doing a little bit of research on these amplifiers, and this switch here can be a source of problems. It's a motorized switch. The reason it's motorized is because this amplifier comes with a remote control, and it's controllable by the remote or the front panel controls, and it's all done by wire, fly-by-wire kind of controlling in this input selection. And yeah, this is problematic, this switch, and so is this switch here. These are problematic as well. They oxidize and then they lose connection on one channel or both or whatever, and then you have a drop channel. So probably what I'll end up doing is removing this switch and cleaning it. This one here, I don't think I can do anything for it because it's probably a sealed unit, and it seems to be working fine. So there's really no point in taking it apart if all the functions work. I'll just have to go through and test all the inputs, make sure everything's working, and then if it is, I'll just give it the pass, the green light. I don't know if you can see this, but some liquid spill in here on the over PCB board. It's like liquid spill. Something's dried up. So yeah, it's going to need some cleaning. Like, this is all crusty. I don't know what that is, but it should be cleaned up. And that's, back here. There's some more. See it back here. And then if you go down here and look at this board, it's not as bad, but when you get, it's pretty dirty. Yeah, it's going to need some cleaning for sure. I'm just wondering how I'm going to do this. I don't really want to take it all apart just to clean it, but I might have to. This looks like it's all one big board. Let me zoom out. This looks like it's all one big board here. Goes across. The heatsink just straddles it. And there's openings cut for air. So, it's quite a bit to this. I don't know if you can see this, but on a few spots on the board, quite a few spots, well actually it's 3 so far, 4 that I've found so far. Look what happens when I turn the lights out. The little silicon rectifiers are glowing like an LED. And there's a number of these all over the board. They're glowing red. Move the cap out of the way. But it's just, if you look at it, it just looks like a regular silicon diode. Pretty cool. So power consumption is pretty stable at about 21 watts. I've been having it on about 15 minutes now. Let me turn up the voltage on the... So now we're at 103 volts. That steps up to 24 watts. Still very good for an amplifier this size. You gotta remember that we're using about 2 or 3 watts for the standby transformer as well. So, okay, so what I'm gonna do is just a quick power test here, just to test for any unusual distortion. I got the load connected to speakers B. I'm going to turn it up here. And I'm limited by my isolation transformer as how much power I can put into this thing. See how much it goes. Right now we're sitting at 102 volts, 37 watts, 38 watts. Let me put you up in the scope. Let's turn this thing up. Yeah, we're clipping right here. Where are we? Right there. We're only at 17.47 and our power dropped quite a bit, so we're at 91 volts on line voltage. Let's turn this up a little more. Let's turn it up to, now it's a little higher. Let's see what we can get up to. There's clipping there. Back it off to about there. Getting 19.2 volts. And the line's voltage sagged again, so let's turn it up one more. Okay. So we got 103 volts. 103 volts, 217 watts going in. So that's that clipping. We got 21.33 volts RMS on the output. I thought I was a better performer than this. I thought this was a lot higher. But we're getting clipping right there. So that's where the limit is. Let's have a look at some square waves. Oh boy, look at that. So that's 1 kilohertz. Let's take it up in frequency. No, that's actually 440 hertz. Okay. That's 1 kilohertz. Let's go 2, 3, 4, 5, 6, 7, 8, 9, 10. This is looking really good. Look at that square wave at 10 kilohertz. Unbelievable. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 kilohertz. And about 10 volts RMS on the output. Let's keep going. And about here is 45 kilohertz. Starting to lose our signal, or our shape. And it keeps going and going and going. That's 105 kilohertz. Pretty much lost our square wave altogether. This is a really good amp. I'm pleased. So here's a 1 kilohertz tone, square wave tone. In direct, turn it to tone. See, the amplitude drops a little bit. You get a little noisy switch here. And then, but then we have our tone controls. There's bass boost, bass cut, treble cut, treble boost, okay, there's our balance. Everything's working normal. Attenuation. It's a dirty switch. Yeah, a dirty switch for sure. So that's going to be on the list to do. What's this switch? Subsonic. Doesn't affect it much. Let's turn the frequency down to 100 hertz. And we'll see our subsonic. That switch is dirty as well. Yeah, I'll clean both of those switches. One channel switching, the other isn't. I guess before I get too far along, I want to take a look inside the bottom and see what's going on here. Let's get this out of the way. I want to disassemble as much as I can and clean it because this thing's filthy. It's just filth everywhere. Alright, what do we got here? We have a nice, clean printed circuit board. I don't think it's been worked on. I don't think anybody's touched it. It all looks good. So let's see here. This one. Oh, this one. Come on. Okay, not much happening under here. Dust. And it gives us access to our bottom of our filter caps and power supply section here. Some corrosion. Bad corrosion right there. Okay, I had to think about this, and I was wondering, why am I not getting full power from the amplifier? It's only getting 60 watts. This amplifier is rated at 80 watts per channel, and I was expecting to see closer to 90 watts per channel, and I saw 60. So I'm wondering, did somebody already replace the power transformer in this? And I got thinking about it, and to tell you the truth, I think it might have been, because if I look down here, you can't see. I'll zoom in. If you look down here, you can see the posts where the wire wrap for the transformer windings come out. And they're wire wrapped on there, but then somebody's cut them and soldered wires to these. So there's wire wrap and solder. Same on up here. Somebody cut the wire wraps and soldered wires, these two wires here. These are primary of the transformer. So I'm thinking somebody did actually change this transformer. Now I don't know the first thing about where would you even find a transformer like this, because these were never marketed in North America. So I don't think Onkyo even made a transformer for 120 volts. These are made for 100 volt. But these are 63 volt caps. So what I'm going to do is I'm going to flip this around. I'm going to connect the voltmeter, power this thing up. We're going to see what our rail voltages are. And if it's low, then we can assume that somebody replaced the transformer for me, which would be awesome. Because I have already ordered a buck transformer. And I had intentions of installing this somewhere out of the way and dropping it from 120 down to 100 volts. But if this is the case, then I don't need this. And we can go just raw dog it all the time. Alright, here we go. I'm going to plug this in. And we are going to power this up and see what we get. Okay. So 103 volts going in, and we only have 45 volts on our rail. Which is low. For an amplifier this size, that is low. Tandem outputs, yeah, that is low. I'm going to say that somebody replaced this transformer. Let's plug it into 125 volts and see what it does. Alright, here we go. We got 122 volts. Turning it on. And we get 55.5 on our rails. That's more like it. I think that's more accurate and more correct. And yeah, it looks like this thing is able to run off 120 volts. No problem. Awesome. So that saves me installing a transformer and the cost with that and the hassle. So this is turning out to be a lot better than I anticipated. Shut this off. Yeah, so we just need to clean. We got some bad switches here to take care of. They are located right here. I'll take the front off. This thing's filthy. Let's start cleaning and working on it. Alright, just plugging away, doing disassembly. I'm trying to get, my goal is trying to get this main board out because it needs to get scrubbed. If somebody spilt something or threw up on it or something, I don't know. You can see all kinds of crusty stuff going on around here, here, and it's all over the board, and it's been wet with something. So I wanted to get the board out. It's not going to fit in my ultrasonic, but what I can do is I can wash it under running water, under a sink, and just with a brush with running water. Don't have to use any soap, just use a brush and water, hot water, and just run the water on it and brush it and get rid of all the trash and stuff that's in there. And then when you're done, just take it and dry it off with compressed air. That's usually what I do, and then you can put it in on top of a hot plate or something that keeps the heat and drives the heat up and out from the board. See, I've got this one. This one's not that bad though. It's got a little bit of a stain on this side. So what I got to do is remove this switch, and this relay, and then I can just dump this whole thing into ultrasonic. This thing needs to go in the ultrasonic. It's filthy. Just things like that. This board here too. This power board. Somebody replaced this transformer. I was curious about that because I don't know where they got these parts from, but somehow they replaced the transformers and upgraded it to 120 volts AC. So this will get cleaned as well, and just general cleaning. It needs a lot of cleaning. It doesn't look really dirty, but it's got, like I said, somebody spilt something or did something here bad. I can see crusty stuff going on all around these resistors. These ones too. So yeah, that's like I said, my goal is to get this main board out, and this board here maybe too, but it's all connected on the bottom. I don't want to disconnect the wiring. So we'll see how I can get along with cleaning up this mess. Yeah, I know it's ugly. Avert your eyes, but this is, I got this to the point where I think I can now take this. I have to cut some ties here, but I can now take this and I can wash these boards in a sink with running water. I removed the relays, I removed the switch. There's nothing else in here that can really get damaged by water, so I'm just going to go for it and clean this all up. It looks pretty dirty. I found a couple of rat turds drop out of it when I was cleaning, taking it apart, so I'm not pleased with that. But I did get the switches out. These need to be either replaced or cleaned. I don't know if I can clean these. They're quite dirty. They weren't behaving very good. I'll see if I can source some new ones. If I can't, I'll clean these ones. And this is the volume control board. Another switch I need to remove and clean. I got one switch out. Where's the other switch? This one here is out. These switches can be disassembled and cleaned now. Alright, and then the rest of this can go straight into the ultrasonic. I can put all this stuff in here in the ultrasonic and let it rip. But this I want to take a little more care. So I'm going to do that now. I think I'm just going to give it a wash. Alright, done washing the main board. It came out really nice. It's nice and clean now. I was pleased with the results. I thought it actually came out better than I thought it would. And all I did was run that under hot tap water. Really soft bristle brush, like a paintbrush. If you don't want to use a hard bristle because you're knocking over components and stuff, really soft. and just get in there and just dab and swipe, and it takes out all the crap between the components, and the running water washes it all away, obviously. And then I just hit with compressed air to dry it off, and it's been sitting overnight and it's mostly dry. I'm pretty sure it's good enough to go, but I might just put it on some heat just to let it roast. Put it on top of an amplifier or something for the day, and just let the heat from the amplifier come up, and you know, it'll dry it out. So I got these out. These are the switches that are causing the problem on the front panel. These are pretty common switches. You can get these on AliExpress. Just search for Alps push switch. This is an Alps switch. You can see that branding there, and it's a 6-pin double pull, double throw, and you can get these. They're 8.5 millimeter body size. Yeah, and you can order these. They're the exact same switch that they used, and they're all made in China, so it doesn't really matter. So I did order some of these, but they probably won't get here for another week or two anyway, so I might just clean these to see how they respond to cleaning. And if they don't, I can always go back in with my brand new switches and replace them. Does anybody know why they put this tape on here? I have a feeling it's just to keep the fins from singing. Just to kind of mute that. Let me see here, let's pull it off. It's all petrified from the age and heat. Can't get this tape off, it's cloth tape. Oh yeah, I think that's why they did that. So I just ruined that. But really, is that a big thing for these amplifiers? Is the heat sinks singing? I don't know. I'm going to go without it for now. But let me know in the comments. Here's a look at the record selector switch. You can see the oxidation on it. Now this switch isn't that old. I think this amp was built in the 90s, early 90s. I don't have any date codes. I'm going to look around and see if I can find some date codes. But yeah, early 90s, so it's 30 years old. And it's starting, you can see the oxidation starts on the ends. That's where the oxygen gets into the switch body from the holes. But the inside's pretty good. I'm going to polish this all up. This will all clean up nicely. And put this back in service. Get rid of the black and make it shine. And just put it all back together. Okay, there it is. We're all back together. Now, I didn't show pretty much anything I did to this because it was just disassembly, cleaning, and putting it back together. Didn't do any repairs other than a new power cord. Put a new power cord on and grommet to hold it. Yeah, that was all the repairs I did. Pretty much. Well, I removed these switches. There's one here. There's one underneath for the moving coil, moving magnet switch. I removed that one and that one. And there was one other one here. This one here on the volume control board. I removed that one as well. This is the direct. And then the two monitors. Direct source direct and two monitors. So I redid these three switches. And these three switches here I also cleaned. Now I used 401B, yeah, 401B on this, and it kind of jammed up the switch, like it's not working properly anymore. Like it's sticking. I don't know if you can see that. But I did order new switches, so they're easy to change out. I can just remove the faceplate, remove 4 screws, the board comes out, and I can pop new switches in. These ones I used Deoxit F5 on those. That seemed to work a lot better. But this one here, okay. So I'm ready to do a power test. Let's wire it up and do a power test and see what this bad boy can do. Yeah, I'm kind of curious. I don't think we have any problems to sort, so let's just go ahead and do a power test. I did find somebody put a 15 amp fuse in this spot here. It's only supposed to be 3.15 amp. So I took that fuse out and replaced it with the proper size. Kind of curious if it will blow the fuse on 120 volts. I don't think it should. I don't think it will. But we're going to do a full power test and we'll see what happens with that fuse. Alright, I think I'm all ready for a power test here. I have everything connected. It's just a matter of turning on the power. And the relay click. It shut itself down. Power. 4 watts. What's going on here? What is happening? I popped the fuse. Look at that. Okay, let's change that fuse. I think I'm going to upsize the fuse to 4 amps. And then we'll see how it goes there. Alright, take 2. Alright, got a new fuse in. Let's try this out. Turning it on. And we got power this time. I don't know why that fuse would shut off. Okay, there's our tone. Direct. Let's do it in direct. Let's do our power test in direct. Different inputs. Okay, let's shut this off. And that's my load now. Okay. Take this up. Full power. Here we go. Okay, let me adjust my scope a bit. Let's see, there's our clipping. Let's take it back. Right to this point here. Take it right there. I got 28.50 volts RMS on the output. So let's let this cook for a while. 360 watts going in. I don't know if you can see that. Let this cook for a while. Okay, we're approaching 10 minutes here, and this thing has been cooking for a good while, and we are getting close to 70 degrees on the heat sink. 65 in the middle. A little closer to 70 on one end. But this thing's doing really good. I'm really happy with this. Yeah, over 100 watts channel. Nice clean power. Nice Onkyo power. So I'm going to shut this down. We already did a square wave earlier on, so I'm not going to show you that. But it's doing really well. A little bit warm. Well, I think it's time to put covers on because I think I'm done with this one. And I think we should move into the listening phase, never mind the testing phase. Alright, so give me a minute. I got 5 covers to put on, 2 in the bottom, 2 in the sides, and 1 on the top. So let me do that. Okay, so I had a day to listen to this thing, and I got to tell you, it sounds fantastic. Especially when you're in the direct mode. Everything sounds so open and dynamic and full. When you turn it to tone, it seems to kind of muffle the sound a bit, and it's going through the tone controls. That could be a function of capacitors, because I did not change any capacitors in this thing, and it's probably, well, it is close to 35 years old now. But when you put it in direct, it really sings, and it sounds fantastic. Another thing I forgot to do is I forgot to add a sticker. I'm going to add that to the back. just so that the next person knows and it's not so confusing as to what's going on with this thing. It says 100 volts in the back, but this is clearly not a 100 volt unit, so I'm going to put this right down here under the serial number, and anybody that looks at that will know that it's ready to go. Now another thing I'm going to do is I'm going to replace that fuse. I put a 4 amp fuse in, and when I was doing the full power tests, I noticed on the ammeter that it was drawing about 3.8 amps of current. That's why that first fuse blew, because it was underrated. And I since did a little bit of research, and an amplifier of this size, the fuse ratings for 120 volts, they had a 6 amp fuse in place, and for 220, 240, they used a 3.15 amp fuse. I'm kind of confused as to why the board is marked 3.15 amp, unless that board has been switched out as well. I don't think it was, but for whatever reason, I don't think that's the correct fuse rating. So I'm going to take out the 4 amp and I'm going to place a 5 amp fuse in. I think 5 amp will work better than the 4. 4 is really close to its maximum rating, so I don't want to have a fuse blow from fatigue just for that reason. So I'm going to take that 4 amp out, put a 5 in, and then I'll be done with that. Now the last issue is power consumption. You can see here, when I first turn it on, it's around 30 watts, but then as you let it sit and idle, it slowly climbs up, and it's at 50 watts now. It'll go up to 75, 85 watts, this amplifier, and it'll get fairly warm. It's got a lot of heat coming out of it. I don't think that's right, and I'm going to go in and fiddle with the bias adjustments. I don't know what the bias adjustments are because I don't have any documentation for this other than a few things I found online, but it doesn't tell me anything. So I'm going to go in, adjust the bias. I don't measure it, see what it is. I might measure it as it climbs up, because it's right now it's over 50, well, it's 51 watts now and climbing. I'll take the measurements and I'll see what it is, and then I'll adjust it down to a more reasonable level. Hopefully that doesn't affect sound quality at any amount, but we're going to go ahead and do that. So let me get the covers off and then I'll bring it back in. Okay, we got some real weird stuff happening here in Onkyo town. Okay, so this has been sitting on idling for a while. Current consumption is climbing up. It's 53. Kind of hanging around 53. It took the covers off. Maybe that's why it's not going as high as it normally does. But watch what happens when I flip this thing up on its edge. Turned it off by that mistake. Okay, flipped it up on its edge. Watch the power consumption drop. It drops quite fast too. Now we're down 48 watts, 47. I don't know what's going on with this thing. That is so weird. I've never seen an amplifier or receiver change its characteristics when you flip it on its side. It's going down at 45. So there is one thing here that I noticed. There's a cap here that's sitting crooked and it's quite hot. If I put my finger on it, it burns. If I put my finger on the next one to it, I can hold my finger on there. Is that cap failed? This cap is cool. It's cool. This one here burns my finger. I'm going to pull that cap out and see what's wrong with it. Maybe it's failing. So I pull this cap out. It's 470 microfarad at 63 volts. I'll get it in frame here so you can see it. It's a Nichicon. Doesn't want to focus, whatever. But look at what I do when I test for leakage. I got 60 volts. quite a bit. It is really leaky. And wait for that to charge. Very leaky. In that it kind of stops right around here. See there, it kind of stops charging. And now we're just measuring leakage. And that is about, what is that? 3 or 4, sorry, 3 or 400 microamps. 300 there. So I think I might just end up replacing these caps. There's another one right beside it. It checks fine. It checks fine with ESR and voltage and all that, but ESR and capacitance. I got a voltmeter connected across one emitter resistor. I'm just going to check and see what value we got here. Let's turn this thing on. It's weird when I power it up. Sometimes it comes on itself. Sometimes it doesn't. So we're sitting at 29 watts right now going in, and we have 0 biasing. Hope this is correct. Yeah, we got 0 bias. So, oh, here it comes. Okay, so I'll let this warm up, and we'll see what we get. Yeah, something really weird and funky going on with the bias on this amplifier. So I was just reading 10 millivolts, now dropped to 300 millivolts, or microvolts. Let me see here. Let me measure. Back over here I was measuring nothing. So let me tie into this emitter resistor. And we'll do a test on this one. There's 300 and some. Let's do the one beside it. 300. Where are we here? We gotta connect here and here. 180. Let's try this other channel. Gotta be so damn careful not to blow anything up here, I think. Between this and this. 5. Okay, that looks more normal. And then on this one, and this one, 5. Okay, let's check this side. Five. 6. Okay, so what's the problem with this channel? Some weird stuff going on here. Part of the problem is I have no documentation on this at all, so I have no schematic, no service manual, no idea what the bias should be set at. Looking at similar amplifiers, similar size, they said something like 17 millivolts across the emitter resistors, but that was on a single-ended unit, not a tandem. This one's tandem. We got a problem on this channel. Let me see if I can poke around and figure out what's going on with the bias on this channel. Seems like it's stable at 36 watts consumption, but we don't have proper bias. Okay, so I'm tweaking the trim pot for this side, and it brought it right up to 6.5. Consumption is now at 41 watts. Let me see if maybe that was just the problem, was the pot was out of adjustment. Let me check this other resistor. Six, okay, that's good. Let's check this side. Where's my resistors? Here's one. 6.6. What do we got on this side now? 5.3. Maybe that's all it needed. I still don't know about this 41 watts. It's 42 watts. Let me lay it down again and we'll see how it climbs up while it's turned on. As soon as I lay it down, it starts climbing up. Isn't that ever weird? You see that? How it's going up now? And a couple minutes later we're at 70 watts and climbing. This will go up to 85 watts and it's really, something's unstable here. I'm going to use my heat camera and see if I can figure out what's going on, where this heat is going. Maybe there's a component failing, or maybe I can use some cold spray and maybe trigger the power consumption to drop again. Maybe I can figure out where it's coming from. 87. Now it's at 95. So what I can see, these two regulator transistors here are really hot. They're over 115 degrees Celsius. Let's see here. I can get this one. It's over 115. This thing's getting quite warm. What does it measure? About 45 degrees right now. Now we're at 106. I'm going to use a little cold spray on some of the semiconductors just to see. I'm going to watch the watt meter just to see what happens. Yeah, look at that, it dropped 40 watts right there. That side doesn't seem as affected, but this side dropped from 100 down to 47. I think I got some bad transistors here or something. A bad resistor. Right in this area here. I sprayed it. And it dropped to 40 from 105. So I'm thinking maybe a bad resistor, drifty transistor. Let me see, it's staying down now too. Bet you if I blew some heat on it, it would go right back up again. Let me investigate this area right here. I might pull these transistors out and check some of them. Could have a bum transistor here. And it's starting to climb back up again. Quite a bit of current on this one channel. That's the emitter resistor on I don't know which channel it is, but it's climbing up here, climbing up here. I'm going to adjust it just because I think this is the cause of my problems. It's just a bad adjustment. Let me try this. Drop it down to 10. Look at that. Maybe the pot is bad. I don't think so. Work the pot back and forth. You can see when I crank it right up, we got 130 watts. Let me turn this down to a reasonable level. Let's turn it down to 20. Let's leave it there for a while and see how it stabilizes. I should be monitoring the other channel as well. But I don't have clips for the 1 meter. So let's just do this channel first. Try and get it stable. See, now it's kind of hovering around 16. I could live with this. I could live with that. Not 100 watts, but I could live with 50. But yeah, let's see how stable this is. So at about 17 millivolts, and is going through a 0.33 ohm resistor. We're getting 50 milliamps on the through the output device. And if I go times 110 volts, which is our plus minus rails, I'm getting 5.5 watts on that pair of transistors. Now, there's 4 such pairs like that in this, so we would be looking at 22 watts or so for the entirety, and I think we're close, because 22 watts, 55 minus 22 watts, that leaves us down around 30. So I think we might be okay here. I'm going to let this stabilize and see if it just behaves or what goes on. I'm going to check the other channel too. Alright, so this time around I did bias adjustment both channels. I replaced 6 capacitors. I don't think that was really necessary to do that, but I did it anyway. There was a couple of 220 microfarad at 6.3 volt caps. They measured down under 200 microfarad. I replaced those. There's a lot of heat in this area, but I don't see a lot of damage from heat. That's the thing. This is like a low hours amplifier, and hasn't seen a lot of heavy use. So, but it might in the future. So let's put it all back together and put it back on the listening bench. Alright, so that's it for this one. I think it turned out really nice. This faceplate here, this black anodized aluminum, it looks really sharp. Once I cleaned it up, it looked terrible before, but once I cleaned up all the fingerprints and smudges and smears, it really looks nice. And these knobs, they're solid aluminum. They do have a plastic insert, but they are solid aluminum, and they got a nice feel to them. This Onkyo is really, really sweet. Too bad it doesn't live up to the rest of it. It's got some bad scratching on top. The sides look kind of beat up. I bet you could clean it up some more if you put some elbow grease into it. But there's some scratches and scuffs in the top. Yeah, so this is going to go on my listening bench, and I'm going to have some fun listening to this one. And then after that, I don't know what I'll decide to do with it, but I'm sure going to enjoy it while I can. Alright, take care, and thanks for listening, and we'll see you on the next one.